The second FRQ in the 2023 FRQ series deals with something close to my heart, electronic signage. I just built my own sign for my home light show. In this FRQ, we're going to build a sign class and calculate line breaks within the sign's message. All the code we're going to cover, including the runner classes as well as the APCS questions, can be found in the GitHub link below. You can download the examples and follow along. Use the test runner classes to test out your answers. Let's get started. The second FRQ we're going to cover is an electronic sign. The electronic sign and the text to be displayed are represented by the sign class. All this code, again, is in GitHub on the link below. All you need to do is to clone it or download it, and you should be able to follow along with us. So please feel free to pause this video and do that. You can follow along with the sign and the FRQ2 runner. So looking back at the sign has a constructor with two parameters. The first parameter is a string that contains the message, so we're going to store the message. And the second parameter is an integer that contains the width. So let's do that right now, since that's pretty easy to do. All I need is two variables. I have a string that holds the message and an integer that holds the width, and a constructor that takes in the message and the width and stores them. It's easy peasy. The next thing I need to do, if I transition back, this is the way that the sign is going to behave. Essentially, I have a width of a sign, which tells me how many characters wide it is. It can accommodate however many lines, but it's always whatever the width is. And then it has the message. So if I had a sign that was 15 characters long, and I passed it the message, everything is on sale, please come in, it would look something like this. It would need to wrap the message into 3 different lines. If it was 17 characters long, I would only need to wrap it once and have 2 lines. And then if it was 40 characters long, I wouldn't need to wrap anything at all. It's just all on the same line. In this particular sign class, we're going to need to create 2 different functions. The first function is called numberOfLines. Once I've created the message and the width, this function will return how many lines that get wrapped. In this case, it would return 3 because it needed to wrap twice, and the message is split up across 3 lines. In this case, it would return 2. In this case, it would return 1. So it just tells you how many lines are needed to display the message. The getLines function, the second message, is going to be returning a string where every time it needs to do a line break and go to the next line, it'll put a semicolon on here. So back again for this first example, you can see that the string has the message all the way up to the S, and then a semicolon where it needs to wrap the next line, and a semicolon, then it has the remainder, which is just the E space N. What we're given here is a list of all different kinds of steps. So we initialize a string and an X, and we create a sign, and we spit out the number of lines, and then we call the getLines twice. And that's essentially what we're doing here in the examples. One of the examples we need to pay attention to right here is this example with an empty sign with no values. Instead of, by default, you'd think that it'd be 1 line, but really you're going to return 0 instead of 1 line. Keep this case in mind as we create it. Let's go back to the code. We've already got our constructor. Now let's implement numberOfLines. First thing is we're going to take care of that base case that we talked about earlier. First thing is if the message has no length, it's an empty string, we're going to return 0 instead of 1. So simple case, we're taking care of the base case. Otherwise, we're going to take the length minus 1, divide it by the width, and then add 1. So you might ask yourself, well, why are we doing that? Well, let's take a look at the behavior. Why don't we just divide length by width? Well, if I take a look at this particular case, what if I was to just do length divided by width? I've got a message here that's just under 10. I have a message that is divisible by 10, and then I have a message that's divisible that should split divisible by 3 times. So it should be 10, 20, and then the remainder is 6. So one of these cases is exactly divisible by the width. One of them is less than the width, and one of them is more than the width. So given that, here's what the expected should be. It should, the first one should be 1 line. The second one should fit on 2 lines exactly, and the third one should fit on 3 lines. So if I was to run length times width, this only works if it's divisible. So it only works in this second case. The first case, it should be 1 line, but it really comes back to 0 lines. So if you think about it, 4 divided by 10, integer math gives you 0. 26 divided by 10, integer math gives you 2. So it doesn't round up to that next level. So we could take the opposite. Well, why don't we just add 1? Well, if we did that, if I was to run this again, If I just added one, then the first and the third one are right. That's 1 and 3 lines, but the second one is wrong now because I've got exactly 20 and I'm getting 1 extra line than what I need. If I was to always take the length of the string and subtract 1, I should always have the case. So kind of shifting it down to shift it down 1. I should always have the number of lines that I need. So essentially what I've done here is take the length minus 1. So it'd be, in this case it'd be 3, 19, and 25, and I divide it by the width, and then I add 1 to the end of it. I should get what I'm looking for. 1, 2, 3, and that works. I could do something like int a equals message by width, and then I can say int b is that mod width, and if there's any remainder, if b is greater than 0, return a plus 1, otherwise a. I could do that as well, and that should work. Let's see if that works. And it works. So essentially what I'm doing here is I'm dividing it, and I'm checking to see if there's any remainder. If there's anything that has a remainder, I'm going to add an additional line for that remainder. So you can do that as well. Now that we've covered that, let's take getLines. We'll first start off with initializing the variables. So what do I need to keep track of? Well, I need to keep track of the new lines. So this is what we're going to return is lines. I'll just finish this up here, just say return lines. I also want to call my previous function here, numberOfLines, and then I'm going to keep track of the starting index. Every time I get a chunk, I have 3 chunks. I'm going to get this chunk first, starting at this position and ending at this position. The next time through, I'm going to start at this position and end at this position. And then lastly, I'm going to start at this position and end at this position. Also, what I want to do at this case, I want to take care of my base case here. If I don't have any lines, I want to return null. So let's take care of that right now. We already have number of lines. If it's 0, we want to return null. So we take care of that. Now we want to loop through and add a new chunk. Let's also take a look at, we want to split each chunk up with a semicolon. We don't want to have a semicolon if it's the first time through. As we have in this case, the A, B, C, D, E, F, if we only have one line, we don't want a semicolon. So we'll never have to add a semicolon if it's the first time around, the first chunk. Every new chunk, we're going to add a semicolon at the beginning. So what we're doing here is, if it's not the first time through, we're going to add a semicolon to the start of the chunk. Next thing, every chunk we're going to split it by the width. So we're going to, the first time through it's going to be 1 times the width, the second time it's going to be 2 times the width, calculating that last index. Now the last one, if we have a remainder, we don't want to go beyond the message because we'll get an array index. So we want to account for that. If we get to the end and the end is longer than the message length, we just want to set, if the end is longer than the message length, we want to set the end to the message length. That way we never go over when we're getting each chunk. And lastly, we want to add the chunk. So we get the starting index, which we calculated. We have the end index is where we're going to end the chunk. We add the chunk to the hold variable, and then we start the loop again by making the start index the end index. And we continue through till we're done. And finally, we return lines. If you're following along with us, it's time to run the runner and see if we have the answer. What we have here, put out here, so we're going to make sure the output matches what we have here in our example. You can see here we have the exact same test cases. We should see the same output. So if I run this, and we get exactly the same, 3 ABC ABC, 3 ABC ABC, 1 ABCD, 1 ABCD, 1 ABCDEF, 1 ABCDEF, 0 and null. We have 0 and null. And lastly, we have 4 and ABCDEF. And that matches. That wraps up the second FRQ.